Hey guys, and welcome to week five, part A. We extended week five this week as part of the fact that I'm traveling and everything else. So we were taking week five a little bit longer and gonna keep making videos throughout this week and next, and that will be week five. And then the course will just end a week later. But hopefully people have been using it to catch up on their builds, building their second board, and just getting to know the stuff a little bit better. So it seems like there's been really, really good activity on the build logs, lots of people participating there, and I'm really, really happy about that. So I am at Maker Faire right now. We got Bri, Pedro, and Brooke here. We're going to talk a little bit about the boards and take some questions. And we'll also have the Q&A app as well up if there are any other people on the chat. You should be able to ask a question there. So, guys, how did this week go for you? Where are you in the build, and what have you been doing? Pedro, why don't you start?
So I'm officially up to date and then some. I follow your advice and start building the small stuff in advance.
Oh yeah?
Yeah, I got this little guy installed too. So yeah, I guess I populated the surrounding of the TSOP and the DAC and the ADC. I populated all the surroundings. So let's see how I go with that. I had my first Magic Smoke release.
Yeah, I saw your poster about that. Yeah.
Yeah. A bit of solder wire, and poof, off goes the regulator. And the inductor does a funny noise when it starts smoking. Then it pops. Yeah, but it's an experience. There goes 5 hours tracking three broken parts.
Yeah, well, it's good you found it. It's always tough too, knowing about if it actually hurts the traces as well, right? I think we've sized our traces large enough, but there are situations where if an overload, it's possible that the board could actually be hurt as well. So it's important to test. It sounds like you're doing all that stuff well. So that's good.
He tested
creative destruction.
Yeah.
Yeah. Cool. Bri, what about you? So Bri's coming in first time joining from New Zealand. It's 4 a.m. there. He wins the most dedicated award. Closely followed by Pedro, who's been up at 3 a.m. in the past.
So this has been my big catch-up week. So I've been quite busy and got a bit behind in the build. So over the last couple of days, I've got all the adjustable regulator and power section all up and running, and got the relay section all done, except I've left the relays off, and also with the terminal blocks and things, I left them off just to make it a bit easier on myself.
Yeah.
To get at the smaller SMD parts on the top side of the board. But I tacked one on just so I could hear that wonderful clicky sound.
Yeah.
And see the light, and that was pretty cool. It was a sort of a nice sort of achievement. Sort of a bit bummed we didn't put any LEDs on the power side, so we have glowing lights when the power's on. That'd have been another nice little achievement. Next revision.
LEDs everywhere.
Yeah, pretty much.
Yeah, that's a good idea. We could do each module having its own LED.
As long as they're not the blue ones. Those I don't know why all electronics seem to use the bright blue LEDs that just make you go blind when you're sitting in the dark.
Yeah.
And I've recently just put the op amp and bits and pieces on, and just doing some preliminary testing with that, and just generating the signal small enough so it doesn't hit the rails through the differential part of the instrumentation amp is interesting. And I think I had a little signal generator, but I think down near those levels there's just so much noise out of the DAC output. It's a bit hard to tell how well it's actually working all the way through. With the 1-to-1 gain or the less than 1 gain, it looks fairly good going all the way through. I haven't tried to do any sort of real hard and fast measurements, but it does look like it's working. I've been trying to go through the schematic and understand the instrumentation amplifier a bit better, especially around sort of grounding of it, and because when I hooked my scope up, it was bouncing around a bit, and I'm not sure if that's because my signal generator was just floating its negative, and since it wasn't tied to anything,
Yeah.
So I've got some understanding to do around sort of what's going on there and where the current is going. But other than that, my board seems to be working great. All the voltages look nominal, and I haven't struck any problems. It all seems to be quite close to the performance I'm seeing on your board in the video. So
Yeah.
it's been good.
Good. Brooke, how about you?
I this week finally got going again. I was determined to find the sawtooth wave with absolutely no success. I tried on the Rigol, I tried on a DSO Nano, I tried on the Gabletronics, no sawtooth. So after talking to you and some other people weren't seeing it either. That gave me those 3 days I lost. I got back on track again. I'm caught up through the LED. I'd say for me, I'm not in a big hurry necessarily to stay current. I am trying to keep up with the videos, even though I'm not actually assembling or testing at that time, just so I don't miss out if there's some scheduling stuff going on.
Yeah.
Plus, then I see the video the second time around, and it's that much quicker when I actually go to build or test. But definitely the build logs, because I'm doing the videos, I'm doing some editing in it, are probably more than 50% of my time. So I know that's slowing me down a little bit, but for me it's worth it because then I have a place I can kind of look back on YouTube to whatever it was I did and double check myself.
Yeah. Yeah, that stuff's been...
My voltages are there that way, so if I can't remember what were the voltages I got, I can go back and go, oh yeah, I got 10.38 or whatever.
Yeah, that's awesome. Yeah, I mean the videos have been really great, the stuff you've been doing. So that's I really appreciate you doing that. That's
Thanks.
awesome. So, I have something to say, and I'm a little worried about it, but I know we're gonna get through this together, guys. Everybody watching at home as well.
Chris is working for Altium.
No, not that.
No.
The footprint's wrong for the 3901.
How bad?
It's pretty bad. So, it's a perfect TSOP footprint, but you know what? That's different than an SSOP. So he's just like, no. So actually, one of my friends here, Charles, he came up here last night to the room, and we were brainstorming about it, and it is going to be challenging. But you know what? I think we're going to be able to do this. What we're going to do, basically, if you take, so what you guys should do later today, you'll see it, right? It's just wider. That's all it is. It's the right pitch and everything. SSOP is just wider than a TSSOP. So what we're going to do is, if these are the legs on an SSOP, we're going to fold them under like an LPCC or whatever that is. Those old 44 pin, you know what I'm talking about? The ones where like the pins curl underneath. We're going to do that, and it's going to work, and I promise it's going to work. Of course, it's the hardest footprint to start with, but I think we're going to be okay. We're going to drag out of the crap out of it. So I was I was back here in the room making the video on Friday night, and I found that, and I'm just like, I'm going to bed. I can't take it. So, but talking to friends about it, I've been complaining about it all weekend as well. Talking to friends about it, you know what? This is real life, right? This stuff happens. It's stupid on my part, but this just happens, right? We have to learn how to bodge stuff, and this is a workaround. And we're not going to be doing. I think the fact that we can fold the legs under as well is going to help, because otherwise it would be like trying to wire individual wires and with like 30 gauge. That would be terrible. So. Sorry. I did also say that I would offer to buy everybody parts if they mess up their MCP 3901s in the process. So I'll buy people parts if they mess up their own. So it's going to be a challenge, but it's going to be doable. So this is just real life. You thought it was going to. This is like the part in a movie where it's like, what was it, Kill Bill, where what's her name's like, you thought it was really going to be that easy? So, yeah.
I remember telling you I was hopeful that we'd have to deal with some of these kinds of problems because that'd be more realistic. And you were like, ah, no, I hope we don't have anything like that. Here we
Nothing
are.
like this. I would hope for like, like a wire going in the wrong place, right? That's easy, right? One wire, you just cut a trace and go over there. This is, yeah,
We are wired going to the wrong place, right? It's just like what, 12 or 16 of them.
20 of them, 20 of them.
20 of them. There we go.
Yeah. Yep.
And I got 3 boards to do, so I get to do it 3 times.
There you go. Yep.
Lots of practice.
Yep. Hey, Margaret, welcome.
Pretty funny there, Chris.
Yeah, I don't know if funny is the word I'd use, but how have you been?
It happens. I'm glad I'm not the only one that makes mistakes. We've all been there.
Yeah. How's your build been going?
I'll get through it. No big deal.
Okay. So, what other questions do you guys have?
Are you keeping the BOM and the schematic and the PCB up to date when you're changing out resistor values or anything like that?
No, because a lot of that stuff is actually we're gonna actually end up changing it back to what the bomb is, right? So a lot of this stuff are like oh, not that one. What was it? It was the 1K and then the 0 ohm here, right? That stuff is all just for testing. We'll actually end up
okay.
stuff once we actually populate the main things. So I don't think there's a lot of reason to update the bomb for that.
Would it make sense to rub the board with Oshpar, Chris, so that if we ordered some in the future, would have the chips correct?
That's a good question. We are gonna, there will be a Rev 2, but I'm hoping that'll be at the end of this session 1B. We'll be actually working on the Rev 2 changes, right? So not just fixing stuff, but also improvements. And the real question for that is actually not for. I mean, yes, everyone will be able to go and get one of those as well, but the real question for that is how to do it the next time if we run the course again, right? So,
Okay.
like, do we show the mistakes over time, right? It's like a Back to the Future type question, like how do you go back and change history, because then everything kind of ripples forward, right? So, I don't know.
I just look at it like any other project decision. It's just, how incremental do you want to get? It would be easier, obviously it would be easier to, especially for people like me, to have a part that fits, right? And that's no big deal. So do you want to take an incremental hit and do all the Gerbers again and send those, or wait to the end? And it makes sense to batch it and do it at the end so that the next course, or if we want to do another board, then we have all the revisions that we went through this class learning. So it's a good experience either way.
Yeah. Yeah, and another thing I was thinking about too is like, okay, so say at the end of this, the part, we just can't get it to solder properly or something like that. We can do other stuff too. Like another realistic thing that I was already thinking about is we could take the output from the op amp, which we see has been working, right? We have videos of that kind of stuff, and we could go patch that into one of the other analog inputs, right? We would have less resolution, we'd have less overall ability, but we'd still be able to measure stuff, and that's a realistic workaround as well. So it's just kind of how much do we want to try here in order to, get the final thing working. So this is the realities of real time, real world design. So.
Well, I think the real positive here is exactly what you said, which are what are all the different things given this constraint, what are the different ways we can approach it? If we choose not to solder it, what kind of functionality do we have, and just have a discussion on that. Yeah. I would turn it into definitely a positive on it. Like, for example, when your ATX didn't work initially and you found out you didn't turn it on, Well, actually my power supply blew, and had I not seen that video, I wouldn't know to short the power on with the ground and try it, and that's exactly what was wrong. So all that debugging thing was actually more beneficial than had it just worked.
Yeah.
So maybe it could be something like that. That if you don't solder the chip, this is the functionality you have and your workarounds around it.
Yep. So what other questions do we have?
Did anybody ask about Maker Faire?
No, not yet.
How's it been? Anything exciting you've seen, or anything?
I've been doing videos with Hackaday all day yesterday, so there will be a lot of that stuff on the site. But my favorite thing so far, electric front loader, like a shovel, like a car thing.
Yeah.
Completely RC, completely electric, completely RC. This guy was driving around and pick and stand up. It was the coolest thing. It was like a Tonka truck on crack, It was just like, and it was all controllable from a little keypad thingy. It was crazy, and like heavy duty. It was like for excavating nuclear sites.
Oh man.
Yeah, that stuff will all be up. What about Project Margaret? We went through everybody. How's your build been going?
Um. I wish I could say better, but it's not going bad from the standpoint of I've made so many mistakes, but then I've benefited from the comments that different folks have helped me with, like Brooke and the different folks in Thomas and all. I think little things like my DMM blew a fuse. So, it took me a while to figure out, oh, I'm not reading the current, and it took a while, oh, the fuse blew. So, but just to know to do a continuity test and then to change the fuses and find out it was pretty easy and not, threatening. And then, for me, I'm just kind of more at the 101 stage probably, where I'm following all the power traces around, just to getting to know because it's new to me to go from a PCB to schematic and going through that. So I'm getting a much better feel for just the soldering things, but I'm still kind of like around the adjustable power supply. So I'm behind everybody. I'm watching the videos. The more that my point is I've been learning tons about the debugging of it, following the circuit around, reading the volts from that, reading the currents. And so that's been very educational, checking out each ATX pin to see, how it maps and things. But certainly not as mind-blowing as some of these posts, which, I'm thrilled to watch. So,
yeah.
Interesting.
Cool. Okay, what other questions? Brian, come on, man. You're up at 4 a.m. You got to give us something here.
That just means that if I ask a question, it'll probably be a rubbish question. I don't know. How are you feeling about like the ATX as the sort of way we chose to power the board now that we've sort of started the build and you've been carrying it around in your portable lab suitcase and things like that? Do you wish that we chose a smaller power solution, or?
Well, for the portable case, it's actually kind of worked out well because what happens is the way it's set up, it actually pulls the air intake through the phone, and then it pushes the air back out. So it actually works as like an ad hoc solder fan, right? Fume extractor. But the real thing that I'm interested in, and probably in future projects, is taking, this thing has so much power that we're not really using, right? The ATX, even on the 12-volt rails, it only does like a couple amps. Not even a couple, I think it's like 1 or 2 amps. That's about the max what it can do. And that's really the rails that I would really like. And what I'm looking at least for the portable stuff, is I want other power rails. So like building like a 5-volt to 40-volt boost converter, right? So actually building other products and peripherals with this kind of thing, right? I'd really like to be able to do that because ATX is so ubiquitous. So I think for now it's been a good start. It's a little bulky, but it's readily available. What do you not like it though?
I don't know. It's just a little bit bulky for my taste, and it's been interesting reading people's sort of when they haven't put enough load on their power supply, and it's led to like droopy rails and other fun things because of the sort of design parameters for most power supplies. They're designed to be quite loaded, whereas we're like not even really loading them at all. It's sort of
that's a really good point. I mean, we're really not using it to how it's designed, and so that can add. I mean, I guess across the spectrum of all the different power supplies as well, right? There's such variation, and that's something that we have seen. People using older supplies there's these noise bursts. Like the one that I got happened to be quiet, but not if you didn't get that same one, or even if I bought a different one in the future, it's very possible that kind of stuff could also manifest in ATX. So yeah, that is true. I guess I was thinking about what other stuff we could do. I mean, we could do, I guess, like a wall wart and stuff like that, but
yeah, I couldn't think of anything easier. either. It's like they're just so common and
Yeah.
cheap compared to output of anything else. And you get a plus minus rail for free and things like
Right.
that.
And actually, I don't know if you guys have anyone, Margaret, you said you shorted something? Mine, when I touched I shorted the -12 to ground at one point, just like the probe kind of crossed over, kind of bridged two pins. And mine snapped off. I don't know about anyone else's.
Well, mine turns off occasionally. One thing I wanted to know is like I said, my first one, I heard a pop or a ping, and then it stopped. It was dead. And it was the one you recommended. And so I went back on Newegg, and there was a couple of unfavorable reviews, and I'll probably end up writing one too. So I then ended up taking the one from my 6-year-old PC, and that's one of the reasons I like what you did, because I can just go through my PCs and start, feeling good about being a hoarder. And
Yeah, yeah, exactly.
the ATX connection is a hard one to deal with because mine gets in so tight it won't let go, so I can't easily undo it. And so it's a bit of a challenge. I think it's a smart choice. I'm not sure about the choice that you had as far as quality control of the actual power source itself versus others. But of course I'm jaded because mine blew.
Okay.
And I wasn't really doing anything at the time. It just popped. Off we went.
And so you didn't try turning it off? It didn't come back?
I tried turning it off, unplugging it, turning it back on, and I tried it several times. And then I tried the test where you do the power on to ground with the wire. It didn't work on that one, but it worked on my one with the PC. And actually, the one with the PC runs a lot more consistently than the other one did. The other one would stop occasionally and then start, and then I had to turn the switch off and start it back on. So.
Yeah, I mean, so Brian, back to your original thing. The other thing we could have done, and a thing I'd like to do in future courses, is actually just go straight off line power, right? But then that's another thing with safety, like especially. Are you guys 240? Is that right?
230 and 50 hertz.
Yeah.
Yeah, that would be very complicated. It'd be nice to get something that is easy for us all to use, and the power supply does fit the bill for that. And
we could. I mean, there are other options out there, right? There's a lot of standard 24-volt ones, especially with like a lot of LED stuff these days. A lot of industrial 24-volt stuff. Those can be pretty noisy as well. But yeah, maybe that's something to look at in the future. It's definitely a little bit smaller. You can get like those. Like I used to when I was my last job, I was using the 24-volt. Like they were tiny. Like 5 amp 24 volts. So maybe that is something to look at in the future.
Yeah, the ones that I've been looking at, probably the most common are the 12-volt, sort of 1 to 2 amp range. But that doesn't give you a lot of sort of headroom on the rails, which is the other nice things we have with plus minus 12. So
yeah. Right. Yeah. I mean, we'd have to do a buck then, but then we'd also have to do some kind of charge pump like Margaret does on her project. Brooke, did you say you were using 24-12s before? It seemed like you were nodding your head before.
No, I was just agreeing that there are those smaller wall warty type supplies.
Yeah.
Probably for me the biggest hassle is the wiring harness and the connector. Like if there was another cable that we could put between the regular connector and our board that was smaller, a lot less thick, so that way the cable, when you go to move your board, the power supply and the cable aren't both moving.
Yeah.
That would probably be better. I don't know if there's a good solution for that, because then I could just tuck the supply up on my shelf and have a nice thin, lightweight cable that you don't really hardly notice when you're moving around. Plus, the other thing I noticed is because we have with the pins coming out of the board, which will be really convenient for making a case, those pins are really easy to run your hand up next to.
Yeah, these.
I don't really want to be the short across those pins, but it's really easy to do that.
That's a good point. Yeah, we're talking about safety, right? Yeah.
Yeah. If they were down, if we didn't do the 90-degree off the edge of the board, if they were straight down, probably I'd be less likely to bump against them because I can leave the board setting on the bench. But when it's on the bench now and I put my hand to the left to try to get it out of the way to take a shot or whatever, I'm always looking like, how close am I to the connector?
Yeah.
And, this doesn't help either, right? The wedding ring or whatever, that's kind of a good conductor.
That's bad. Yeah, that's probably not a good idea to wear that in general.
I should be taking it off, but I just don't think about it.
Right, of course.
Until probably I weld myself to the connector.
Yeah, I mean, the only thing that's usually a saving grace, I mean, so usually with you have to be pretty wet to conduct 5 volt, 12 volt kind of stuff. So skin resistance is pretty unless you have moist skin, it's usually you won't conduct very well. But yeah,
As
it's
we
still
get, I'm in the garage. As we get into the summer, my skin will be moister.
that's true. Yep. Here comes Dave. Look at this, trying to get a certificate last minute. So Dave's been doing great work this week as well. He's been going back through and doing the work that I didn't. So Dave's been posting the parts for as replacing them. He's been posting those into the threads on the associated forum. So thank you very much to Dave for that. That's been great.
He's also been all over IRC. I don't know what he does outside of contextual electronics. He's a busy guy.
Putting out fires, probably.
Yeah. He's also probably a volunteer fire person. There you go.
So Dave, how's your build been going?
Pretty good. I ran into a small snag with the current section, so I'm still working on that. It's behaving oddly. I think I screwed something up.
What's oddly?
It's pulling a lot of power. I can hear the fan of my ATX power supply like kick in when I short the Arduino pin to the DAC out, and the FET starts getting pretty warm.
Okay.
But the current, like, as I turn the pot, the current starts to go up, and then it like collapses. So, could be a bad ATX power supply. I don't know.
Interesting.
Hopefully.
Okay. Well, yeah, keep us updated on the build logs and stuff. That'll be a good way to keep updated with that. So you're doing the voltage through the divider to the op amp input. That's the one you're talking about, and then that's hurting the 12. That's controlling the 12 volt, and you're saying the 12 volt falls out after a certain point.
Yeah, I have my meter hooked to the output, and I'm shorting it with the meter in amp mode, so I can read the amperage, and it's like 12 milliamps, and it goes up to about a 30 milliamps, and then it just falls back down. But you can hear the ATX power supply really working.
30 milliamps, it's working. It's weird.
Yeah.
Because that should be up like 100 or so, shouldn't it? I mean, like.
Yeah. It should have been like 100 to like 190.
Yeah. Okay.
And everything else has been to spec that I've measured, so I'm not sure what's going on.
Okay.
Like I said, hopefully it's just the supply. Maybe like the supply is bad.
Can you put a dummy load on your supply and just see if the supply can take it?
Yeah, I was kind of starting to. I put a dummy load on the bench buddy just to see if like the direct short of the meter was too bad. I put like a 75 ohm resistor on there, and then I just started doing stupid stuff. I decided to call it a night.
I know how that goes.
Sets in.
Yep. Cool. Well, so this coming week, so we're going to start digging into this snafu that Dave, you probably have not heard about yet, but I don't know if you were watching earlier.
Unfortunately, I was time zone challenged again.
Our footprint's wrong for the 3901, so terrible. So we'll be digging into that, though, and I think we're going to be able to do that. And we'll be able to do the DAC as well. So overall, I'm disappointed in myself, but I'm not too worried. I saw that, it was, shoot. Someone started doing Arduino sketch stuff as well. I don't remember who that was.
I'm excited to look at it. Thomas wrote some kind of test harness.
I didn't hear that, Margaret.
Thomas?
Tom, yeah, that's right, Tommy. Yeah, Tommy Perry. Right.
Yeah, so I'm excited to look at it. I really applaud his initiative.
Yeah. So that'll be interesting as well, especially as you start, putting the parts down and stuff. So, what other questions do we have?
Well, I wanted to follow up on Brooke's point about the pins on the cable connection. Perhaps the power, it's a nice power supply because it's inexpensive and it has a lot of different options on it. But the board seems to use, what would you say, out of all of those 24 pins, the board uses what, about 5 of them, 6 of them? Doesn't use that many. So to Brooke's point, perhaps a cable between the two that took the 24 pin, turned it into the whatever it is, 5 pin, and then had the connector for that one with a longer, more like a power cord. Because I believe the biggest challenge with that power supply is what Brooke said, which is I have like tons of different cables coming out of it. Then it's unwieldy on that, and then to Brooke's point, all of the pins on the board itself, and really that points to the just coming up with the cable, having the cable be just like a power plug that goes to a box that I could put on a shelf somewhere would I think would be fine, and we could even make a molding around the power source so that it can sit off to its side and doesn't look so unwieldy. But that's it.
Okay. Well, that's good. I mean, that is interesting too, because I mean, making cables is a very difficult, not very difficult. It's an annoying thing, but a lot of people have to do it, right? So it's a good learning experience too. So that might make sense in the future. I do agree it's unwieldy. It kind of gets that twist, right? If you're not twisted perfectly.
Yeah.
You just staple the power to the bench. You guys are good, right? That's a bad idea.
I did have a question, but I don't know how it's related to AC noise, but it's not, which I seem to have my fingers in quite a bit. But I think I don't know how much it's related to everything. I was thinking the parasitic noise. I was reading a data sheet where they were talking about increasing the oscillation, and I assume that they were doing that because if they increased the oscillation, then they could get rid of the parasitic noise that was on the AC, and they were dealing with MOSFETs, but I wasn't sure. So perhaps this question's out of line, but it was one that was to do with AC noise and diminishing it.
Yeah, we might have to deal with that if when we start doing PWM on the current output, that actually might become an issue, right? So the idea there is that how FETs are set up, they're actually, like, if you start diving down on the component level, they're actually really cool, right? So basically, it's like a capacitor, and then basically the capacitor actually controls, on the other side, that actually is what the isolation between the input and the output is actually a capacitor. By charging one side of the capacitor, that actually is what turns on the silicon on the other side. That's basically how a MOSFET works, right? And what happens is you have to start worrying about that because when you start putting in AC signals, right, the actual capacitance of that gate starts affecting what AC signal you put in there, right? So as you go from a DC signal and start raising the frequency at which you're toggling a FET on and off, what happens is you have these shoot-through effects where you start to effectively have different the FET basically starts to act differently based on what your input is, right? So if you put in a gigahertz signal, it actually no longer will charge up that gate very well, and it starts to affect that kind of stuff. And so that's when you start to have to worry about not gigahertz, but the AC component of that starts to matter more when you're actually starting to excite it at a higher frequency.
So here's an example. This chip I'm looking at has 4 MOSFETs in it. And it says, okay, it has a boost pin, and if you use the boost pin, then the oscillation is increased 6 times. And so then I checked the AC noise, and it literally halved it with the boost pin when the boost pin was hooked up to the voltage pin. And so then I started looking up MOSFETs and parasitic.
Yeah, Margaret, unless I don't know what you're talking about. This is a different part, right? This is
okay, but it was dealing with to your point, it was dealing with the MOSFETs increasing the frequency.
Yeah, right. Well, we can talk about that. I mean, we do have our private sessions. We can talk about that.
All right.
Yeah. Pedro, what about for you, man? I haven't heard anything since the beginning. So what kind of questions you got going forward?
Yeah, I have one important thing for the next revision: the power lab. I watched him.
Oh yeah, that looks nice. So what?
I
That's just to check the
bodged
power.
in, yeah, power on, so I don't change the op-amp settings with the power on.
Oh,
I changed it far too much time, and then I bodged in the LEDs, but that's uh, pretty pretty handy signal
yeah.
to have.
Is that just? Did you have a?
I
Can you show that
just
one more time?
yeah, I
Okay, yeah. So you have
bodged it in
yeah.
ground and 5 volt.
Okay.
So when it's on, the LED goes on.
Yeah,
But it's
that's a really good idea.
pretty handy. It's pretty handy, maybe for the next revision.
Yeah.
Yeah.
Yeah, that's good. I mean, yeah, the only way I can do that is with the fan, hearing the fan. You know, that's the only way I can really check, and if it you get used to that noise.
No noise. I got a fancy supply, and it's absolutely silent. I cannot hear it.
Yeah.
So, of course, the LED.
Yeah, that's good. No, that's a really good idea. I like that. And yeah, we probably should start compiling a list of add-ons as well. So like other things that we want to put in, and kind of keeping track of what other things we'd like to see in there. I've had a couple things that I'd like to see. Um, the real question too is as we move towards next revision, we got to get this stuff working still. But as we move towards next revision, how much do we really want to change it, right? Do we start to shrink the board maybe to try and get lower cost board, right? Do we try and add other stuff in, right? Obviously, we're going to move some of this. We have to fix some stuff. Some's like a must fix. Some's a want to fix. Some's a nice to have. That kind of thing. And just kind of keep track of that as we go forward.
Yeah. And last week I promised to test the thermistors,
Yeah.
the PTC thermistors. I forgot. I don't have a load. So,
Yeah.
didn't do that. I am trying to search the web on how to build a dummy load. Then I'll try and test it. But it hasn't been easy.
Yeah, that's a good point because some people do have. I saw someone post about their Arachnid Labs, the reload they had, and a lot of people do have dummy loads, right? I mean, that is good to have around. So, does anyone else have one or no? Yes, no.
I'm the one with the Arachnid Slabs reload.
Oh, that
It's
was you.
quite handy. Yeah.
You
I
actually
bought
gave me.
I bought a Menuo, but I haven't put it to test yet because I tried to solder to some pins and they started to lift off of the board. So I changed direction on that.
Okay. Yeah, I mean the having DC loads are. It's always like you don't know you need it until you need it, right? That's the thing, and so we could also build one. We have one, right? I mean, this is effectively could act as a load circuit if you tune it right, but it's not. The resistor's not very heavy, so yeah.
I've seen the video that Dave did on his dummy load.
Yeah.
And I'm trying to build one, but that hasn't been easy. So I'll keep up.
There's a couple on Tindy as well. I think that's pretty common on Tindy to be able to buy like just a PCB and source the parts yourself. So that might be another thing to do. To look on there. But yeah, it's tough, right? If you don't have that already going, it's
Arachnid Labs recently did a Kickstarter for sort of a bigger version of their programmable load, which is you can control over USB and give it profiles and stuff, which would be quite nice for making it easy to draw graphs of that power supply droop when it's being loaded and things. So,
yeah. That was pretty pricey though. Wasn't it like 130 or something like that?
something like that. Their little reload too, which I have, I think was down $40 range or something.
Okay.
So.
Yeah, I'm looking at Tinker right now. The Reload Pro is 125. So, yeah, you can buy them.
Yeah.
But maybe that's something to look at as well. I mean, that might be a good thing to have on hand. But it is a good project to build as well, Pedro. So that might be, good to keep going with. Often it's that finding a good sensor system and then having a nice capacitor system. That's usually the bulk of it.
Yeah. I would recommend the MOSFET that reloads have. It's got nice thermal runaway properties and will shut down and that sort of stuff. Yeah.
Which one is it?
I can't remember. I was looking at the data sheet.
Yeah. Is it the IRF 450? That's the one I always end up seeing.
I can't remember. No.
Okay, that's fine. Yeah, there's some good parts out there. Those Fed guys, they know how to make good parts.
Oh, actual real question. So far, we've been leaving the sort of little SOT protection diodes off, like on the regulators and stuff, Chris. Would you be able to speak to like why it makes sort of things easier at this stage, and when you would probably actually start putting them in, having those protection diodes there?
Why it's easier at this stage, Brian, is because I forgot to order them. That's the answer right now. So the reason to have those, I think we talked a little bit about this last week. Basically, having those there, those are going to be acting kind of like my coworkers used to call them silicon fuses, right? Because it's gonna, if you start having rise in the output, it's really for noise. But if you start have a significant DC rise in the output, they're gonna pop, right? I mean, so. And the reason we put them in because the datasheet told us to put them in, right? So that is not a good reason, but it's a reason. And so it works, and it seems like it's. I don't know. Pedro, you said you blew out a circuit. I think Margaret said you blew out a circuit, but I don't know if that's actually from this. Usually it's from active stuff pushing back. The reason those are there is when you have an active load that can actually push the stuff back into the circuit. So, or like even like an inductive load where you don't have a flyback diode, right? And it pops off, and it same kind of thing.
Yeah, in my case, it should have been popped. The regulator would have popped also because there was a bare wire across the whole box.
Oh, gotcha.
I don't think they would make much difference.
There's no solution for that, huh? Yeah, and I mean that's kind of the heart of it, right? You can have the biggest diode in the world, but if your current's high enough, and if your voltage gets high enough, nothing's gonna save you. Like there is no perfect diode. Everything can die a heat death at some point. So, yeah. So does that answer your question, Brian, or no?
Yeah, no, it's all good.
Okay.
I was just wondering if there was like a bigger reason, or if it was just.
No, it's mostly you.
Yeah, that's all. It's all good.
I have found. So I was surprised actually. I've been finding that I need a solder sucker gun more than I thought I would. Have you guys been finding this at all?
It was pretty hard to take out those TO220 packages without the solder sucker. Weak it out, but I managed to change it, but maybe the solder sucker would have helped in my case.
Yeah, I use the solder sucker, then the wick to try and get the last little bit out, and then it's the dancing across the pins to try and keep them all hot enough to push it.
Yeah, I've never had good luck with solder wick. I've always used the suckers.
Yeah.
Or anything through hole, I agree.
Yeah,
through hole stuff, definitely.
Right.
But the SMD stuff, I've not had any trouble with the solder wick. That's worked fine.
Yeah, right. I've been having so basically what happened when I was doing assembly, I put the ones in on the bottom, and then I was like, oh, this is easy. And then I put another one, and it was like popping out the top, but I was coming the wrong way, and I'm like, oh, jeez. So I just cut it out, But that was the point where I'm like, I think they're cheap too. Like they're like $5, right? I mean, that's kind of a reason to have one is because it's cheap.
Yeah, the top of the end ones are like 20.
$20.
Yeah, like $5 to $20.
Oh, okay.
But
the best ones have that. It's like silicone rubber on the end.
Yeah.
So you can smash it right up against, and then it really creates good suction.
Yeah, it doesn't melt.
Yep.
So another thing.
Sells those.
Oh yeah. Okay. Another thing I purchase and I'm going to be trying out. I've actually never used one before, and I'm not sure if there's someone on here that suggested it, but an embossing tool. You guys ever seen these before? Brooke, I didn't hear you.
I hadn't until you sent a picture of one.
Oh yeah. So yeah, on the chat, right, on the IRC.
Yep.
Yeah. So these things are basically they're art tools, right? Basically, it's a hot air blower, right? It's meant for doing embossing, but like they're cheap, and I think they could be used for reflow. Maybe like it's really grunty, right? It's not temperature controlled. It's like you get what you get. Brian, you'd have some trouble because it's only working on 120. So yours would be trying to output twice as much temperature. It would probably melt itself. But there might be 240 versions out there as well. But basically, it's like a cheap hot air reflow gun, like $10. Like SparkFun has one. I forget what they call it, but it's like it's basically they got it from China and they called it something else. I don't remember what the name of it was, but basically I'm going to be playing with that when I get back as well. Oh, it's called the Heaterizer, the SparkFun Heaterizer, and it's like $10. The XL3000 heat gun, and that's kind of used for heat shrink tubing, right? So when you're making cables, you put the heat shrink on, and it makes it collapse around the wires. But in a case where you're trying, like you were saying, where you have to try and keep all of the pins hot at once, you kind of when you have a heat gun, right, you can kind of do that a little bit better, as long as you don't melt the board. So, yeah, we'll try that out too. I mean, it's kind of like these small hand tools, trying to make sure we have all the stuff we need. You don't know you need it till you need it, that kind of thing, right? What else? I hung out with Lane yesterday. Purple. That's fun. What other questions you guys have? Nothing? Okay.
Aha, got it. I was muted. I got my Captain protected Captain protected Arduino.
Nice. And that's working okay?
Yeah, I got my LED clicking once a second. It's a blink with a sound.
Nice. Okay, good. Good. Yeah, I think Jai on the forums as well. He wrote about how to actually. I think he was doing pin lifts so that it had extra headroom. There are extended headers you can get as well that might be good for this. And actually, wait, hold on. Sorry, I got a toy. There's a guy at TI yesterday who was actually. Oh, this is crazy actually. So this guy is doing a kit. He walked up to me. He's like, "Hey, I'm doing this kit. It's an analog. It does analog in, analog out. It's an Arduino Shield. It's got boost on it." I'm like, "Holy crap! You did a bench, buddy." Except he's doing it as his PhD thesis. So we're like doing PhD level work here, folks. But you see the extended pins he has. He has the same kind of thing. So it might be worthwhile just for us to get that kind of thing.
This one.
What is it? Oh, you have those too. Okay.
Yeah.
Okay.
I ordered a bunch, and I had this lying around. So
okay.
Use them.
Yeah, so I'll have to post links to these eventually as well. Maybe people could buy these and Solder Sucker at the same time because you probably needed to get all these out, right? I mean, that's kind of the Bench Buddy upgrade.
Are those longer than the ones that are sold at Adafruit and SparkFun?
Yes. Yeah, these are non-standard. So if you look, the standard ones that are sold actually is the same height as what we have on here, right? It just has the header and then the standard height here. I think they might sell the extended ones as well, but you can see the difference in terms of. Can you see that? Overhead difference.
Yeah, I can see it now.
Okay. But yeah, this is sweet. This is $50 too. This little thing. It can do 30 kilohertz audio though. So he was the dude's pretty smart. He did a 4-channel MIDI where he did a mixing with the which is like a R2R mixing type thing, and he had 4-channel MIDI output from this thing. He was playing Toccata and Fugue or whatever it is, with a MIDI signal straight out of the Arduino. It was pretty sweet. there's tons of stuff here. I mean, like tons of like Arduino fanciness. There's a bunch of audio libraries now. It's kind of crazy. It's crazy out here, guys. All right. Any other questions?
Here's what the Adafruit ones look like. I don't know if you guys can see that.
Oh, those do look a little longer. So yeah, maybe.
I don't know if you can see. Same camera.
It's amazing how deceiving they are in the board, out of the bird, and then with the little plastic thing.
Right.
I was shocked that those were the same length.
Yeah. Right. Yeah. They look so long when they don't have the plastic on them, right?
And then, I happened to get into that Borderless Electronics Arduino clone. So I've got the one with a little micro connector.
Yeah. That was the $9 one, the one that was for like third world country things?
Yeah, our hackerspace ordered a whole bunch of them.
Cool. Yeah, I think a lot of people switched away from the A-type USB?
Yes.
Yeah, that's bulky, right? I mean, you can't even find cable. It's getting harder to find cable. You still can, but it's not like your other electronics. Usually most electronics using micro or mini USB, so I think it's worthwhile to do that.
And at the hackerspace, everybody's carrying a cell phone, and we all have cables to recharge our phones.
Right.
So you already have that with you.
Yep. Right, that's what they did for pricing. They did that so they got better pricing.
Sure.
So any other questions? Otherwise, I gotta go give a speech. Oh wait, hold on, sorry. James wrote in, is there a current limit problem with L2 and L3 spec to 105 milliamps? 105 milliamps. I'm not sure I know. I mean, L2, L3 is the these guys, right?
The one on the bottom. I noticed it yesterday. It was getting pretty hot, the one on the bottom. It's on the 5 volt rail.
The 5 volt rail, when
it's the L1. It's on the bottom.
Yeah, it's getting hot just from. I mean, we're not really using 5 volts, are we?
Yeah, I don't know, but it was pretty hot yesterday. I didn't check out what it was, but we are not using 5 volts for anything, right?
You've been using 5 volts, haven't you? Have you been testing the opto?
Yes, that's right. Yeah, Dave, you're feeding back there.
Oh, sorry.
But that was just wired over, so I don't think. I'll have to test that on mine. Actually, I don't know. I haven't filled down there yet, so that's good to know, Pedro. I'll check that out. But I think James is saying L2, L3, which is the 12 volt ones. So 105 milliamps shouldn't be that bad. The current limit problem with. I'll have to look into that more. So James, if you're still watching, I'll look into that some more. All right. I think we're good. I think I gotta go give a speech at Maker Faire. I haven't practiced much.
Good luck.
I will haste it.
What was that?
Good luck.
Oh, thanks, man. Yeah.
You'll do fine.
It's talking about the program, so like you guys are easy to talk about, right? I mean, it's like, my buddies, my pals, It's good stuff. So I'll talk about the Hangout and everything. And no one's probably gonna show up. Let's be honest.
Oh no, you'll get plenty of nerds.
Yeah. All right, guys. Well, thanks for showing up today. So next week I'll be probably it's gonna be Sunday because I'm traveling all day Saturday. So next week will be Sunday, probably afternoon-ish. Brian, if you want to stay up again, sorry. In the few weeks.
I know I'm traveling next week as well, so I'm sort of like doing a massive catch-up session, and then I'm away for a week, and then I'll be doing another catch-up session when I get back. But maybe I can do a bit of Arduino coding, and I'll probably try and get my current bit done before I leave, and I'll take it with me. So
bring a mobile lab. That's what I do. All right, guys. Thanks for showing up today. We'll talk to you next week.
Okay.
Thanks, Chris.
Thanks,
Bye.
guys.
Uh,